Ryan is a senior software engineer who specializes in service virtualization and test data management. And Alaska has some pretty intriguing, complicated issues that they're dealing with. And it's always fascinating to hear Ryan talk about that. So Ryan, I don't think I'm going to take up any more of your time. I think I'm just going to let you run with it. Ryan, we can't hear you. You might be on mute.
There's 3 buttons to do. Got to make them all
There we go.
There we go. So I am a senior software engineer at Alaska Airlines, specializing in service virtualization and test data management. And today I'm going to tell our story, essentially how we tested the untestable and solved the environment dilemma. This is really like a very good continuation of the work that Herminio just presented. First, let me tell you a little bit about ourselves. We are primarily a West Coast carrier servicing the West Coast and the state of Alaska, thus the name. Actually, I can turn off the camera too now to keep those slides nice and clean. Servicing really great destinations such as Hawaii and Mexico and mid-continent and the East Coast. But what's really valuable for us as a business is we've won the J.D. Power Awards, highest customer satisfaction for the last 12 years in a row. I believe in the last few years we've scored first place out of most, if not all of the categories, maybe except for 1 or 2. This is a true testament to how we value our customers. So that's kind of how we run our business. Let me kind of show you how we kind of operate our business. In the center here, you'll see our flight operations manager. This is our system under test. And this keeps track of all of these kind of dependent interfaces you see around the outside. These are all of its dependencies. And what this system does, it allows us to manage all of our flights, where they're going, and the key safety aspect of this is the weight and balance of the aircraft. So in the upper left, we have cargo. Cargo essentially keeps track of all of the dimensions of the boxes or crates and how much they weigh and where we want to position them on the aircraft. Our passenger interface keeps track of where all the passengers are sitting, where they're male, female, if they have lap infant or a child. Fuel is another high variable item per flight. And what this does is, if you've got a longer flight, obviously Seattle to Washington, D.C. is going to need more fuel versus a shorter flight from Seattle to Portland. But what if that flight has more passengers or cargo and baggage on board? You're going to need more fuel to offset that. There's also another piece of that, which is the flight plan, which keeps track of essentially, wind speeds and directions. So if there's going to be a headwind, we might want to add more fuel. Next is flight events. This is in the industry, we call them OOI, which is OOI, which means out from the gate, off when you take off, and on when you land at your destination, and in when you pull in your destination's gate there. This is really the heartbeat of the airline, of it functioning and operating. Next is our crew data. Since we operate different types of aircraft, such as Embraer E175s or Bombardier Q400s or our Boeing 737s, each of those have a different crew complement of flight attendants. So E175 would have 2 flight attendants, but a Boeing aircraft would probably have 3 or 4. Next is our aircraft interface. And really what this is actually our aircraft communications interface. This allows the pilot to communicate with the ground via SAT or VHF communication. Next is baggage. So as a passenger, you're going to be checking your bags and they weigh them there. So this keeps track of how many bags and how much they weigh and where we want to position them out in the aircraft. And load plan is essentially an aggregate of a lot of this data, including a flight plan that also feeds into our flight manager weight and balance system. Well, when we first started testing this, we started finding out some challenges. When we looked at one system, it had dependencies on other systems. And we started unraveling those, we ran into more dependencies. And before you know it, the system became so complex, it was very difficult, not impossible to formulate repeatable tests. So I call this the candy-coated view to kind of tell our story. But this next slide is the actual architecture diagram of the system. And the reason I wanted to show this is to show you how complex of the complexities of what we were faced with. In the center, you can kind of see the little white box. That was our system under test. And all of the tendrils spawning out from there are all of those dependent interfaces and how they reach out to all the other web services and databases and applications, and eventually like satellite communication. So here are some other challenges that occurred for us here. First was environment. We were previously testing in a test environment, which was shared, but had continual changes. Those were such as like code deployments, and which would cause little micro interruptions. And this took a lot of time for us to track that down in the system to see where those are coming from. Next was data. Our systems architect really coined this great term. Our data was integrated, but not coordinated. So we had one database refreshing daily, another one weekly, some monthly, some ad hoc, and maybe some not at all. So this gave us a lot of inconsistencies in our test data. Next was services. These are primarily wrappers to databases, so they're pretty much inconsistent as well. But in the concept of third-party vendors, we may not always get a test version, so it's not available, or we lack the control to control the data there. Next is events. Again, this is previously in our test environments. They don't exist, or we lack the resources to make them happen. And an example of this is such as a pilot responding to one of those messages via the satellite communication system. We don't have a bunch of like satellite communication systems and pilots to respond to those in our test environment. So this was a big challenge. Let's start looking at some of the solutions that we had to solve this testing challenge. We adopted a tool, service virtualization. And this example I'm going to give you is very textbook. On the right-hand side, you'll see our plane side device. So if you board the aircraft and you're looking outside your right side window, you'll see them pull the trucks up with all the cargo and baggage. This is the device that they scan that with to find out where they need to put it on the aircraft. And also tags the system that has made it to the aircraft. Well, that calls into our airport web service, which is essentially a service wrapper to 3 more services: the cargo and the baggage and the passenger. So what happens here is we took and put the service virtualization proxy in between our client device and our airport web service. And we ran through the scenarios that we wanted to test reliably. That now recorded those requests and responses. What we could do now is disconnect all of that background infrastructure, all those web services, and have our client talk directly to our service virtualization layer. This now gave us very repeatable and concise and precise responses to test our software. So this is one aspect of it. Now I'm going to bring you to the bigger picture. And this picture is big and it gets bigger and bigger. So this is one of the first stages. First, we created our own isolated environment. We called it CERT, which is short for certification. And in the center, we've got our flight manager. So that is deployed there. And in this environment, we deployed all the other dependencies, all of the databases, the web services, the applications, the queuing layers, the enterprise service bus, and it is all isolated. There is no cross-contamination from any other environment. Next, we used test data management to solve our database problems. And this is core at 2 pieces. First is we used subsetting. We only selected 1 day's worth of data. This provides us very fast refreshes, so about 5 minutes to refresh all of the environment. The next piece of that is, since we are a time-based logistics company, is date aging. So when it goes to that database refresh, it actually clocks the date 1 day forward. So we are now essentially living in a Groundhog's Day kind of experience, if anybody's seen the movie. Essentially reliable, repeatable data day over day. Next is our service virtualization efforts. First is our passenger service. Now this could be its own presentation. It is so cool what we did here. At its core, it essentially allows us to simulate all the passengers for our entire airline for all flights. But in addition to that, it allows us to give time slices so we can actually simulate passengers going through the life cycle of being booked to checking in and boarding the aircraft. And on the right side is our aircraft service. So all those pilots, what we did is we created a virtual service that allows the messages coming out to acknowledge a load plan and then respond to it that has been read. Another cool piece that we did there is actually simulating another business process, which is fueling. So one of the processes is once it calculates that load plan, it needs to have fuel. So it actually will take and convert a fuel slip, which is sent from the pilot to the fueler, and then it will respond with the fuel on board message, which is essentially the amount of fuel that the fueler's loaded. Next is those flight events, those UIs. Those, again, are our heartbeat. There is more than just that. We also simulate other events, such as pilots checking in for their flight, or gate agents closing the flight once it's complete, or operations actually initializing flights. So what we have here is a fully functioning, coordinated, and integrated environment. This has now allowed us to test our scenarios reliably. So this is essentially stage one. We took this even further. Using this previous slide, we now use virtualization to record all the other interfaces. And as you guess, what does that allow you to do? It allows you to decouple and disconnect from all that infrastructure. So now we had a set of referentially intact messages for all of our flights for an entire day. And we can now take that and feed it to another replay engine to feed it to other environments. We use this technique to drive our performance and our training and secondary automation environments. And I think at one point in time, we had up to 7 environments in parallel running off of feeds like this. Even our business users, so they could actually experiment with their changing of how the business processes work, but in isolation without impacting all the other teams. So let me take you forward and show you what the UI kind of looks like. This here is the UI of that system. Down the left-hand side, you'll see aircraft, which is essentially the physical aspect of the airline. And then across the top, you'll see time and UTC, or Universal Coordinated Time. The blue and red bars are essentially the flights going from origin to destination. And the black gaps in between are what we call in the industry turn time. That's really a key efficiency of how efficient we are in deplaning passengers and boarding them for the next flight. So imagine if you were a tester. You now have to do a test against this flight. You have several challenges. And Herminio brought this up, is the contention around data. Here, you have to wait until later in the day. Well, you have to wait till later in the day to test it. Say you now find a defect. How are you going to get to retest that? Yep, you got to wait till tomorrow. Wait, Murphy's Law, things can always get worse, right? What if somebody else needs to use that test data? So we have this great contention around unique pieces of test data. So using that referentially intact data set, we could now take and clone that to create a new virtual airline, which is this next slide. We could now take and create virtual aircraft, which are the ones you see on the left, and then give it a condensed schedule over time. So you can now provide rapid opportunities for testers or frontline staff to be trained. And so in this example, you'll see it's all blocked and gridded on the far right, and then it's kind of checkerboard in the middle. The one thing we ran into here was we had so much demand for data, we created more data than the system could support. At this point in time, we were running about 1,000 flights a day, and we had over 4,000 sets of these flights in the system. And so we had to disable it. And the technique we use, kind of jokingly, we called it the double div mod. We essentially took the even number aircraft and disabled the even number flights, and then took the odd number aircraft and disabled their odd number flights to allow the performance of the environment to to work as expected. So actually, to close on that previous slide, I forgot to mention one thing. 6,000 of our frontline staff have been trained in that environment, and that really helps us run a very safe and efficient airline. So they are trained on all the safety scenarios that the system calls out, and then also they get to rapidly train to help run us very much on time. So instead of fumbling through and experiences being new, they've already trained for it. So our lessons learned. If you can dream it, you can build it. We started off doing this for test, but that previous slide of the training environment, somebody else dreamed that up, and so we built it for them. And the core part of this presentation is we essentially went from being untestable to testable to now having a thriving demand for more of these capabilities. And the third topic is culture change. For us, adoption was easier if the problem was harder. And I have a good analogy for this. This is kind of like if you're going to a building and you need to get to the second floor, more than likely you're going to take the stairs. But if you need to get to the 10th floor, you probably want to take the elevator. And just consider this as a tool to get you from point A to point B where you're trying to go. So I'll close with that and switch to questions. Over to you, Arthur.
Thanks, Ryan. Maybe you turn your camera on too. Yeah, there we go. Cool. So we do have a few questions queued up for you. One is, it seems like consumer-driven contracts would have been very helpful in this context. Did you consider those?
What is a consumer-driven contract?
So if the questioner would like to expand on that, we'll take that in a moment. The next one was, is the test data management virtualized data or real data copy?
It was a real data copy that was subsetted and obfuscated.
Okay,
And then
great.
also we patched it up with some more scenarios that weren't in the original data set.
Cool. The next one is, what tools did you use for service virtualization? I swear I didn't write that question.
We used Parasoft Virtualize. And then for the test data, we used IBM Optum.
Cool. And the next one is, did you experience any challenges keeping virtual services in sync with the live implementations of the services that they're simulating?
Is what we've had for us over time. There are WSDL or schema changes that occur. And so when we were able to bring those in kind of twofold, the integrated environment was very easy. We essentially just deployed that new data there. But then what we did is we had to analyze what those new schema changes were. And for us, we've incurred this about a couple times. One was where they added new attributes for the underbody, for the cargo holds. And so we actually just used SQL DML to transform our original recorded messages to now bring it back into sync with what the new behavior is.
All right. Well, great. That was awesome, Ryan. I thank you. It was a great presentation. If anyone has further questions, etc., just send them off and we'll make sure that Ryan gets them.